Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everyone, to Wednesday night math night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And I just love what we get to do here, which is help you build your competence and confidence in math so that you can walk into that test feeling more prepared. So we are here every Wednesday going through about 10 problems. It's rare that we actually make it to 10 problems, but we have 10 problems ready to go. And we just help you get ready for that math exam. If you feel like you need more targeted help, you can stay on for the end, and Dr. A will kind of go through some ways that we are here to support you if you need a little bit more targeted help. But these Wednesdays are for you. So if you have questions that you want me to go over in the upcoming weeks, just let me know in the comment box. We have a next week section that we always add to each week. And so there are problems tonight that we will go over that are from the next week section. So if there's something that I didn't go over or something that even while we're working, you're like, man, I wish she would go over this, let me know, and I am happy to add that into the upcoming week's sessions. Before we get started, I always like to do a get to know you question just to make this feel a little more, I don't know, coffee shop-ish and a little less, computer screen-ish. So let me know in the comment box where you're from, what test are you prepping for, and get to know you question. Are you an Italian ice fan? We have Kona Ice coming to our school tomorrow. And it is a special surprise for somebody. But just in case anybody's listening, I don't want to ruin it. But we have Kona Ice coming tomorrow. And it's like, if you've never heard of it, it's like this ice truck that literally gives you a cup of shredded ice, shaved ice. And then they have like the syrups that you can put on it. And like the customer can put their own syrup on their ice. So It's a fascinating concept. I don't love it. I just don't love flavored ice. I would much prefer an ice cream cone or an ice cream cup. But are you a Italian ice or a flavored ice kind of person? So where are you from? What test are you prepping for? And are you a fan of Italian ice or flavored ice or shaved ice or whatever you call it? Hello, Carla. It's good to see you. North Carolina. Kona Ice is definitely from Florida, so you love it. Yes. Hello, your children love their chocolate. I feel like kids love Kona Ice. Like it is their thing. And you're from Florida. Welcome. Hello, Marco. It's good to see you. And which FTCE? FTCE is like the umbrella of all of the tests that the state of Florida has to offer. So which one are you preparing for? That'll just help me kind of guide our conversation tonight. All right, without further ado, let's go ahead and get started with our first question, which is actually a question or a topic specifically requested by one of our people who comes every week. So let's go ahead and get started. Which of the following graphs, graphed on an XY coordinate plane, shows the correct graph to represent the linear inequality 2x minus 6y is less than 24? 2x minus 6y is less than 24. Which of the following graphs graphed on an XY coordinate plane shows the correct graph? General knowledge test. Good to know. Most of what we do every Wednesday relates directly to the general knowledge test because general knowledge is 4th through 8th grade. And so I try to keep a lot of what I do in that range because it hits my elementary people, it hits my middle school people and my high school people. And then I sprinkle in some pre-K through 3 and some high school stuff. All right. So in order for us to be able to graph a linear equation or inequality, the easiest way to do it is to take this equation that they've given us and put it in slope-intercept form. They did not give it to us in slope-intercept form. And so that just makes it more difficult to graph because in standard form, we really don't have a whole lot of information that's helpful. Standard form is not really all that helpful. So in standard form, it's hard for us to pull, hello, Trina. It's hard for us to pull information out that's helpful. So we're going to move this around. We're going to manipulate the equation or the inequality to get it into slope-intercept form. So 2x minus 6y is less than 24. Slope-intercept form is y equals or is less than or is greater than mx plus b, where b is my y-intercept and m is my slope. And so that you can tell very quickly that is going to be extremely helpful because my y-intercept, I can literally go and plot that on my y-axis. And my slope, I can then figure out what my next few points are, and then I can go ahead and graph my line. So I want to get y by itself. So I need to get y by itself, which means I'm going to subtract 2x from both sides. Why am I subtracting when there's a subtraction symbol here? Why wouldn't I add? Well, because the operation that's being done to the 2 is already positive. So 2 minus 2 is 0, which is going to cancel these out, and that's the goal. So I'm left with negative 6y is less than negative 2x plus 24. You notice that instead of writing 24 minus 2x, I wrote negative 2x plus 24 so that it is in y equals mx plus b form. And now I'm going to divide everything by negative 6. Now I'm going to divide everything by negative 6. And because I'm dividing by a negative, this is an important note. When you multiply or divide by a negative on both sides, the inequality symbol flips. The inequality symbol flips. So because I'm dividing by a negative right here, this symbol right here is going to flip and turn around. And so now I'm left with y, because negative divided by a negative is a positive, is greater than negative divided by a negative is a positive. 2 divided by 6 is 1 over 3, simplified. X minus 4. 1/3 x minus 4. Questions? We're not done. Just wondering if you have questions about that process. Now I finally have my inequality. And I can quickly see that my y-intercept is -4. And my slope is 1 over 3. Remember, slope is rise over run. So when I look at my graphs, I'm looking for a graph that has a y-intercept at -4. I'm looking for a graph that has a y-intercept at -4. And we're just reconnecting the iPad, status quo. So this graph right here has a y-intercept of -4. The first thing I'm going to do is check which of these graphs has a y-intercept of -4. And if it doesn't have a y-intercept of -4, I'm going to move on. This one has a y-intercept of 1, 2, 3, -4. This one has a y-intercept of 1, 2, 3, -4. This one also has a y-intercept of -4. So I can't eliminate anything based on that. So now what I'm going to do is I'm going to look for which graphs have a slope of rise 1, run 3. Rise +1, run +3. So I can see that all of my graphs have a positive slope. So I can't get rid of any graph because they have a negative slope. Remember, when we're looking at graphs, we read them from left to right. So if my graph is going up from left to right, that's a positive slope. If my graph is going down from left to right, that's a negative slope. But from left to right, all of these graphs are going up. So I can't eliminate based off of that. But what I can do is see which ones have a slope of 1 over 3. So from this point, I'm rising 1 to get to my next point and running 1, 2, 3. This is a winner for slope and y-intercept. This one right here, my next point is here and here. So I'm rising 1 and I'm running 1, 2, 3. This is a winner for rise 1, run 3, which immediately tells me that this is not going to work. But let's find out why. My next point on my graph are those two. I'm not rising 1 in this case. I'm rising 1, 2, 3, run 1. So the slope of this line is rise 3, run 1. And the same with this one. Rise 3, run 1. So these two can be eliminated. Now I need to figure out how to shade my graph. And the easiest way to figure out how to shade your graph is to pick a really, really easy point, plug it into either your original or your new equation, it doesn't matter, and see if it works. So the easiest point to plug in is always going to be 0, 0, because it's just easy to plug in because it's 0, 0. So if I plug in 0, 0 into this equation, 2 times 0 is 0, minus 6 times 0 is 0, is less than 24. Is 0 less than 24? Is 0 less than 24? Yes, that is a true statement. So I want 0, 0 to be a part of my solution because it's true. So I am going to color the side of my line that includes 0, 0, which means that this is going to be the correct answer. Now, let's pretend that I had a different equation, and let's say we had 0 is greater than 5. Let's say we plugged in 0, 0, and that's what we got. 0 is greater than 5. That is not true. That is false. So you would color the side that does not have 0, 0, like this one right here. That's when you would color the side that does not have 0, 0. If when you plug in that point that you choose and it's false. What happens if 0, 0 is on the line? If 0, 0 is on the line, then you have to pick a different point. 1, 1, 2, 1, anything that is just a little easier to plug in, but 0, 0 is always going to be the easiest because when you multiply anything times 0, it's 0, so you don't really have a whole lot of computation that you have to do. Questions about this problem? That was a lot of information, but I think it covered a lot of different spectrums across what we all need. All right, let's move on to problem number 2. When teaching second graders how to regroup when adding 2-digit numbers, which of the following teaching strategies should the teacher do first to introduce the concept? Draw a picture of the 2 addends and represent how to regroup using the picture. Using an equation to show the 2 addends and how they can be broken apart to make it easier to add. Use base 10 blocks to represent the 2 addends and then manipulate them to regroup and add. Or focus on the fluency of facts because it will make it easier to add 2-digit numbers if they have their facts memorized. All right. So this is obviously a teaching pedagogy question for my elementary and early elementary people, but I promise we'll get to other content for everybody else. When teaching second grade students how to regroup when adding 2-digit numbers. So we're teaching second graders how to regroup when adding 2-digit numbers. So like 36 plus 59. We're going to end up having to regroup these numbers right here. Which of the following, here's our question, which of the following teaching strategies should the teacher do first to teach the concept or introduce the concept? Draw a picture. I'm going to look at the verbs here. Draw a picture. Use an equation. Use base 10 blocks. Focus on fluency of facts. The rest of that verbiage is completely null and void. I mean, it's not completely null and void, but a good chunk of it is null and void because we're looking for the strategy. All of the other is the skill that's being taught through that strategy. So draw a picture of the 2 addends and represent how to group. Use an equation to show the 2 addends and how they can be broken apart. Use base 10 blocks to represent the 2 addends and then manipulate them to regroup. Focus on fluency of the facts because it'll be easier to add the 2 addends. So all of that language is really not helpful because it all just says the same thing in a different way. Draw a picture, use an equation, use base 10 blocks, focus on the fluency of facts. I'm going to order these in the number that the teacher should do them in when teaching this concept. 1, 2, 3, 4. Are you surprised by that? If we are introducing a concept, we are going to use manipulatives to do so. It doesn't matter what you're teaching. If we are introducing a concept, especially at the elementary level, then we are going to use manipulatives because we want to teach students concretely, then using pictures or numbers, then abstract. So we're going to use base 10 blocks first. Then we're going to move to using pictures, and we're going to connect our base 10 block representation to those pictures. Then we're going to use an equation because that's the most abstract form, and we're not going to focus on fluency facts when we're trying to teach students how to regroup. This will naturally come as students practice and learn, but that's not going to be what helps them understand the concept of regrouping with 2-digit numbers. Questions about that? Trina, to answer your question, is the statement true, pick a graph that the shade, if the statement is true, pick the graph that the shaded area includes the point. Yes, that is absolutely the case. Would there be an order like that for teaching questions for middle school teachers? Yes. Really, it doesn't matter. We should be teaching with concrete models. Concrete models may look different at the middle school level, but you definitely want to use concrete models to teach concepts to students. Pictures come next, but sometimes concrete just looks a little different for those more abstract skills. And then picture representation and then abstract. Absolutely. Questions? All right, let's move on to the third problem. Stephen is engineering an open-topped box out of a piece of letter paper, 8.5 by 11 inches. He cuts out 2-inch squares from the corners so he can fold the paper into an open-topped box. What is the volume of his box? What is the volume of his box? All right. So for this problem, we are looking at an interesting question because we have a piece of paper. There's my piece of paper. And this piece of paper is 8.5 by 11 inches, but he's going to create a box out of it. So he cuts 2-inch squares out of the corners of his paper so that he can then fold the paper into the box. And for those of us who are visual learners, let me show you what this is going to look like. I'm going to get a piece of paper. All right, here's a piece of paper. So I'm going to cut 2-inch squares from the corners of my paper. And this may not be exactly accurate because I'm literally ripping it, but I'm cutting my 2-inch squares right now. So now my paper looks like this, right? Because I just cut those 2-inch squares out. And now I can use tape because now I can fold up each of my sides, right? So I can fold that, and then I can fold this side, and then I can fold this side, and then I can fold this side. So I can fold up all of these little flaps now. And I can tape the corners together to create a little box. So like I could put my pencil in the box and it would hold it. I could put my phone in this box. So you can see how it creates this corner that I could tape together. Now, these are not lining up because I didn't cut them out. I ripped them. But if I cut them out exactly, it would create this box. So knowing that, what are the dimensions of this box? Knowing that, like, what's the dimension of this side right here? What's the dimension of that side? If I open it up, it's not 11 because I just cut out a whole chunk over here and a whole chunk over here. It's 11, take away 2 from this side and 2 from this side because this is a 2-inch square and this is a 2-inch square. So it's 11 minus 2, which is 7. And then this side is 8.5 minus 2, which is 4.5, right? 8.5. Yeah, 4.5. And what is the height of the box? What is this height right here? How tall is that? How big is this square? That's what's creating that height, right? So that's 2. So if I draw my box, this is 2, this is 4.5, and this is 7. And they want to know what the volume of the box is. Well, if it's a rectangular prism, the volume is going to equal length times width times height. So 7 times 4.5 times 2. Do that in my handy dandy calculator. 63 inches cubed. Now, I believe whether it was last week or a couple of weeks ago, we solved a problem like this, but instead of finding volume, we found surface area. Instead of finding volume, we found surface area. The only reason that open-topped was affected by surface area is because when we find surface area, we're really just finding the area of each of the sides of my box, right? But there's no top. But having no top doesn't impact how much stuff can go in the box. It might affect how much stuff stays in the box if I walk around, but it doesn't impact how much stuff goes in the box. So open-topped does not affect volume of this box. Questions? All right, let's move on to the next problem. We're skipping this one because that is the surface area, and I believe we already solved that problem a couple weeks ago. Michelle is working on simplifying the following expression using the order of operations. In what step did Michelle make her first mistake? In what step did Michelle make her first mistake? Step 4, step 5, step 6, or Michelle did not make a mistake. So, if you struggle with if you struggle with order of operations, knowing order of operations is PEMDAS, which is please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition and subtraction. So multiplication and division are partnered together. Addition and subtraction are partnered together. And then you have parentheses and exponents. So we're going to solve parentheses, then exponents, but then we're going to solve multiplication and division together. If you struggle with student error analysis and you struggle to find the student error, my biggest suggestion to you would be to solve the problem on your own and then find the student error, especially if you feel competent in the actual skill that the problem is assessing. So what you could do is you could write out the problem and then solve it yourself, see what you get, and then compare. That does take a little bit longer, but that is one strategy that you could use. I'm not going to do that for this problem because I feel confident in my ability to do order of operations. So let's go ahead and look at this. The first thing she should do is solve these parentheses. 3 minus 7 is -4. So 5 times -4, and then she kept everything else the same. And that's what you should do when you're doing a multi-step problem. Then -4 times -4 is +16. 5 times 16, she kept everything else the same. 5 times 16 is 80. 80 plus, she kept everything else the same. Now, we did parentheses. We did exponents. Now we're looking at multiplication and division. We should not be doing any addition or subtraction. So parentheses was here. Exponents was here. Then from step 3 to step 4 is multiplication and division. But multiplication comes first in order of operations. But when we do multiplication and division, we solve them from left to right. So I would do this multiplication first, absolutely. Then I should be doing this division next. And that is not what she did. Michelle did multiplication, and then she jumped over here and did multiplication. So she made her first error in what step? Step 4. Technically, it's from step 4 to step 5, right? So her first error was made in step 5 because we're going from step 1 to step 2. So that would be a step 2 error, a step 3 error, a step 4 error, a step 5 error, a step 6 error, a step 7 error. You can't make an error in step 1 because that's the original equation. So the error would be going into the next step. So the error was made in step 5. Questions? Don't forget that if you have anything that you want to see me go over in the upcoming weeks, we always have a next week section that I am happy to implement and use in the upcoming weeks as I'm building problems. So don't forget about that. All right, let's go ahead and do this problem. The point 2, -6 is graphed on a coordinate plane. Which of the following points lies on the same line as 2, -6 with a slope of 1/2? Which of the following points lies on the same line as 2, -6 with a slope of -1/2? So there's actually a variety of ways that we could solve this problem. We could graph it on a coordinate plane and try to figure it out. So we could do our best to graph this on a coordinate plane. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, and the point is 2, -6. So over +2, down 1, 2, 3, 4, 5, 6. And they want to know which of the following points lies on the same line as 2, -6 with a slope of -1/2. So -1/2 would be rise 1, run 2. Rise 1, run 2. But I'm running in the negative direction because it's a negative slope. Now, you can see that this isn't the most accurate graph because I'm not doing it on an actual coordinate grid. But let's see if we can figure out this answer with our answer choices and our grid. -2, 2. -2, +2. That is nowhere close to my graph. So I can pretty confidently say that is not going to lie on the same line. -4, -3. 1, 2, 3, 4. 1, 2, 3. 6, -4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Probably not. -6, +2. 1, 2, 3, 4, 5, 6. 1, 2. Probably not. If I had to take a shot at it, it would be letter B. However, like I said, they didn't land exactly on each other, and so that's hard. Another way you could do this is create an equation for this line. So we could do point slope form. Why? Because they gave me a point and they gave me a slope. Hence the point slope form. Point slope form says y minus y1 equals m times x minus x1, where m is your slope, just like in slope-intercept form, and y1, x1 is your point. So in our case, we have y minus y1, because this is my y, equals m times x minus x1. And you're like, Amy, what do I even do with that? Great question. Y minus minus becomes a plus, so y plus 6 equals -1/2 times x minus 2. Let's say that I was debating between two answers. Let's say I was debating between letter B and letter D. I could plug both of those into my now equation for my line and see which one is true. So I'm going to plug in D. 2 plus 6. You have to remember that y comes first. So it's very easy. The common error is going to be for people to plug in -6 in for y, but it's actually the 2. 2 plus 6 equals -1/2 times x minus 2. 2 plus 6 is 8. -1/2 times -6 minus 2 is -8. -8 times -1/2 is +4. Does 8 equal a +4? No, 8 does not equal +4. Because that is not true, this point is not on the line. Let's go ahead and try it with the point that we think that it is. So y plus 6 equals -1/2. Let's go ahead and just do a little reconnection here. All right. Okay. So y plus 6 equals -1/2 times x minus 2. Third time's the charm. That's the hope. Third time's the charm. For the love. We were doing so good until the very end here. All right. X minus 2. Now, I'm going to plug in -4, -3. So y, -3 plus 6 equals -1/2 times -4 minus 2. -3 plus 6 is 3 equals -1/2 times -6. And half of -6 is 3 times a negative is a positive. So that checks out, which means B indeed is our answer. Questions about that? All right, let's go ahead and move on to the next problem. Find X if A equals 2B. Find X if A equals 2B. All right, so this is a fun one. I actually really enjoyed this problem. So I'm looking for X, and I have a bunch of numerical values, but I have no numbers here. None. 0 numbers. So how do I even solve that? Well, there are 2 geometry principles that I do know based off of this picture. 1, supplementary angles equal 180 degrees, which means the sum of angles on a straight line is 180 degrees. What else do I know? The sum of angles in a triangle, the sum of angles in a triangle equals 180 degrees. The sum of angles in a triangle equals 180 degrees. So I can use both of those principles, right? I can use both of those principles to be able to solve this problem. So I know that A plus A plus B plus A minus B has to equal what? 180. So A plus B plus A minus B has to equal 180 because they're all in the same triangle. Now, with addition, parentheses don't really matter. With subtraction, they do. But with addition, all it's telling me is that I can add these 2 first, and that's what I would do if I had numbers, but I don't, and addition is commutative. So I'm going to just drop those parentheses, and B minus B is 0. So those B's disappear. So I have A plus A, which is 3 A's, equals 180. Divide both sides by 3. A equals 60. So now I can go back in and plug in 60, 60, 60, and figure out B. So 60 plus 60 plus B plus 60. That's not going to be helpful. So I know that this angle is 60. I know that this angle is 60 plus B. I know that this angle is 60 minus B. Now what? Now we can take these equations and we can substitute. So we have A is 60. We have 60 plus b, and we have 60 minus b, and then we have this x right here. I know that 60 minus b plus x has to equal 180 degrees, right? Because this is a straight line. So 60 minus b plus x has to equal 180. And I know that all of my other angles have to equal 180 as well. What I also know is that 180 minus 60 is 120. So I know that these angles together have to equal 120. Which answer choices can I eliminate immediately? I can eliminate 150 because I want you to think about this. If this angle equals 60, then this angle cannot equal 60 plus 150. In a triangle, I can't have an angle that is greater than 180. So that angle cannot equal 60 plus 150, which would be 210. There's no way. And it can't equal 160 either. If I plug in 100 into A plus B, so let's say B is 100. 60 plus 100 would make this angle 160 degrees. 160 plus another 60 would be 220. That's not possible either because all of my angles have to equal 180 degrees. So what if I did 60 and I plugged it all in? If this is 60 and this is 60 plus 60 and this is 60 minus 60, what is 60 minus 60? 0. Right? So that's not possible either. So then B has to be 50. Wait a minute, we're solving for X. Holy moly, y'all. My brain just went so sideways with that problem because I was like, I don't know how I'm supposed to finish this problem. I was like, I'll start using the answer choices. I totally missed that A equals 2B. I totally missed that I made this problem. Like I found this, like I was like, how am I missing this? A equals 2B. So if A equals 2B, then 60 equals 2B, divide both sides by 2, B equals 30. How did I miss this? If I know my 60, I can plug it into here and I have B equals 30. I was doing way more work than we needed to do. So let's erase a little bit of this. So then if B is 30 and A is 60, then 60 minus 30 is 30. And if this angle right here is 30, then 180 minus 30 equals 150, which means X is 150. I was like, I'm just going to try to solve this problem for them because sometimes this happens. And while I don't want to project that all the time, I'm kind of happy that you saw me be human because you were able to see, like, I got stuck and I needed to figure out what I was doing. I just totally didn't read the problem, which sometimes happens, right? Especially when we're under a lot of pressure taking our test. And so when we don't read the problem, then we don't see that, hello, A is 2B. And then that's a critical piece of information. All right. We have time for one more problem, and then we are going to close it out for tonight. But don't forget to let me know in the next week's section what you want to see me go over in the upcoming weeks. Given the graph, what is the average rate of change from f of negative 6 to f of 2? What is the average rate of change from f of negative 6 to f of 2? All right. This is a high school problem all the way. This is a high school problem all the way, but really anybody could solve this. I need you to know when you see average rate of change, all that means is slope. Now, you and I both know that a parabola does not have a consistent slope because it's not a straight line. However, if we're looking at average rate of change, I'm literally going to use my slope formula between -6 and +2. Between -6 and +2. So I'm going to find my points on the graph. F of 2 is here. Now, the only problem here is that f of -6 is not plotted on this graph. So I know that I need 2 points. I need f of -6 and I need f of 2. F of 2 is 2, 4. So there's 1 point. F of 6. So this parabola, my equation is going to be f of x equals x squared plus 2. How do I know that? Because my f of x original function at 0, 0 has a point at 0, 0. That's not the case. This is not f of x equals x squared plus 2 because I'm not just vertically transferring it up 2. I actually have an a value that's been shifted. So what I need to do is figure out my a value or figure out the patterning here. So 0 over 2 up to, what's my next point? My next point is here. So over 2 up 1, 2, 3, 4, 5, 6. So I know that I would plug in something y minus y over x minus x. And the equation of this parabola would be, you know what, y'all? We're going to come back to this one because I want to be able to solve this one the best way that I possibly can. And I need to be able to figure out how we would find the equation of the parabola. So we can use vertex form. So y equals a x minus h squared plus k. My vertex is over 0 up 2. So y, here we go. Y equals a times x minus h is 0 plus 2. Okay, I was on the right track. So y equals ax squared plus 2. And now I can just plug in an x and a y to figure out. Okay, I was on the right track. So my other x and y is 2, 4. So I can plug that in. 4 equals a times 2 squared plus 2. 4 equals a times 4 plus 2. Subtract 2 from both sides. I'm blowing through the computation of this because if you're taking a high school exam, that part should be easy for you. So 2 equals 4a. So a equals 1/2. So then my f of x equation is 1/2 x squared plus 2. Now I can plug in that x value of -6 plus 2, 1/2 of 36 plus 2, half of 36 is 18 plus 2 is 20. So this point up here is going to be -6, 20. So then y minus y over x minus x, 20 minus 4 is 16, divided by -6 minus 2 is -8. So 16 divided by -8 is -2. Did I do that correctly? I did. So E would be -2. questions about that? So you would use your vertex formula to find the equation of your parabola, find that missing point that's not graphed, and then find the slope for average rate of change. They typically will not give you that many steps in one problem. If they say find the average rate of change, they're going to have both points typically presented for you. All right. I'm going to turn it back over to Dr. A. I will see you next week. Don't forget to let me know in the comment box what you want to see me go over in the upcoming weeks, and I will see you later. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.